Our over-reliance on plastics has seen large quantities leak into land, rivers, and oceans, causing harm to marine environments across the planet. Small pieces, less than 5 millimeters in size, are known as microplastics and can be classified as primary or secondary depending on their source. Primary microplastics spread in the environment through spills and misuse. Secondary microplastics break up from a wide range of pieces of mismanaged plastic, eroded by sun, wind, and waves. In 2017, the International Union for Conservation of Nature released the first report of its kind to identify the different sources of primary microplastics.
There is the visible and the invisible side of marine plastic pollution. The visible is coming from mismanaged plastic waste, 8 million tons per year into the oceans. The invisible comes from these primary microplastics. They come from different sources like the abrasion of tires, the shedding of textile fibers during washing, the loss of microbeads from cosmetics, or the abrasion of different plastic objects or paints. And what we discovered is that these primary microplastics are a very significant source of plastic into the oceans, with an additional 1.5 million tons input every year. Overall, this is around 15% of all plastic into the oceans that come from the microplastics. And this is even a higher proportion in more developed countries with better waste management facilities. For these countries, these primary microplastics even outweigh the contribution of mismanaged waste. We need better tools to measure the plastic footprint of companies and countries in order to close the plastic tap.
What is important to remember is that plastic in all forms, all shapes, all sizes impact ecosystems, some more than others, like marine ecosystems. With the support of the Swedish Postcode Foundation, we started a project in the Baltic region. We also conducted experiment fieldwork in Canada, Sweden, Finland, with implications for the Arctic.
The Arctic region is essential for global climate regulation. Here, temperature and salinity variations cause surface currents to bring warm water, while the denser, colder water returns south. Floating microplastics aggregate in the Arctic, where they are trapped in sea ice. IUCN suspects that microplastics might interfere with the formation and melting of that ice. Covered in ice and snow, the Arctic has high albedo, meaning it reflects solar radiation that would otherwise be absorbed by the ocean. If a dark piece of microplastic is trapped in the ice, it will convert the sunlight into heat and melt the area around it. This could reveal darker surfaces, absorbing more heat and creating a self-reinforcing effect. During the melt, phytoplankton rise to the surface to photosynthesize. This attracts zooplankton, which ingests some of the plastic particles released by sea ice melt. Microplastics then enter the food chain, causing unforeseen consequences for life.
Part of the research we're conducting aims to understand the implications of plastic in ice formation and melting. This is why we partner with the University of Manitoba, trying to understand the possible impacts of plastic in the ice.
In the last few years, what we added to our research tools was a new facility called SURF, or Sea Ice Environmental Research Facility. It is essentially an outdoor swimming pool that's located right on the campus of the University of Manitoba here. We start to formulate the seawater into this pool, and that water starts to freeze.
We increased the concentration of plastics, so we could understand, does plastic impact ice formation? How much plastic is scavenged when ice forms? Where these plastics will be distributed throughout the column of ice? And is there a point where concentration of plastic starts to affect the albedo effect? This is a control environment, which is nice, but we needed a validation. That's why we set up an expedition around the Bothnia Gulf, going to Sweden and Finland to collect samples and see how plastics are embedded in the ice during the ice formation. So we basically collected some ice cores and we shipped it to Canada. So the idea is that we correlate these samples taken in the Bothnian Gulf with the experiment that was carried out in Canada.
The geography of the Baltic region is very sensitive to pollutants since it is an enclosed sea, and the pollutants stay in the water for a very, very long time since it takes almost 30 years for the water to renew itself. The Postcode Foundation is interested in this research in order to see how it can be applied in the area of climate change and eutrophication, and also to identify the entry points into the system and to see what damage microplastics can cause.
It's fundamental to treat the plastic issue not just as a recycling problem, but also beyond that to look at how do we manufacture products, how do we actually design them in such a way that it won't automatically end up in the ocean. Our objective is to bring the latest science and apply it in such a way that it really makes a difference for conservation.